What do you guys want to talk about first? I mean, we're not going to have time to go through the entire review, so I would prioritize the things that you have real questions about. I did post a key to the review. If you go to the Power School calendar and find the review assignment, the key is there. And I'm happy to do things that if you have questions about, but I don't want to just go through this one question at a time over and do everything. You guys are supposed to do these things too, right? If you have questions, that's fine. I'm happy to do things, but I don't want to just go straight through this and have me do the entire thing, because that's really not what you guys need, to be quite frank. But I'm happy to do stuff. And if you have questions about one, I'm happy to do one. But if you're just saying, well, start with number one, like, that's not what this is supposed to be. That's all. Okay? That's fine. Five. Sure. So what do these vertical bars around matrix C indicate? That means that we're going to be taking the determinant. So how do we take the determinant of a 2 by 2 matrix? I take the product of this diagonal and subtract it from the product of that diagonal. So I get 0. Is that okay? Eli? 12? So it says, give a specific example of two 2 by 2 matrices where A times B does equal B times A. Now, can I just pick any two matrices and have this work? No, right? We talked about some specific situations where this does work. Does anybody remember one of those situations? What? Well, we're using matrices. So, I mean, we should be looking for two matrices. Andrew? Sure. So if you use, say, any matrix, let's say 1, 2, 3, 4, and then if I use the identity matrix, that would work. So that's an example where that would work. Absolutely. Good. Is there another situation where this would work? What do you mean by square? The matrix square. Oh, so you're saying if A and B are the same matrix? Sure. I guess it's kind of trivial, but okay. There's a couple more good ones that would be obvious. What if instead of the identity matrix, you just had the zero matrix? Right? That'll work. What are you going to get when you multiply any matrix by the zero matrix? 0. right? The zero matrix back again. So that works. And what would the other one, the other obvious one be? It would be if you use the inverse. Those are the four obvious situations where that will commute. Is that okay? Eli, you feel good there? So there were several examples of things that would have worked. Okay. What else do you guys want to talk about? Grace? 11? Yeah, so what's the... We want a square matrix that has no multiplicative inverse. What's the holdup? What's the thing that can fail that would give us no multiplicative inverse? Well, remember for a matrix, a 2 by 2 matrix, A inverse is going to be 1 over the determinant of that matrix times this kind of like rearranged version of that matrix. So where are we going to possibly get in trouble with on that A inverse? Can we always rearrange a matrix? Yeah, right? That's never going to be a problem. That's potentially the problem. Because that's a fraction, right? When do we get in trouble with a fraction? When the denominator is 0. So what's in the denominator of this fraction? The determinant, right? So what we really want is just a matrix A whose determinant is 0. So what's an example of that? What? Sure, the 0 matrix would work. That's kind of trivial, but yeah, sure, that would work. And really, in line with the 0 matrix, if you have the same element everywhere in the matrix, that'll give you a 0 determinant. Or you could have something like this. Why is that going to give you a 0 determinant? 2 times 4 minus 1 times 8 is 0, right? If the product of the two diagonals is the same, that'll give you a 0 determinant as well. So like any of those would be good examples of that. Grace, does that feel okay there? Yeah? So we saw several examples there of different kinds of things you can shoot for. But in general, you're just looking for something where the two diagonals multiply to give you the same thing. So there's lots of choices there, right? Oh my goodness. No, I know this. Hold on. Nope, it's coming. Oh, no. It's not. What is it? Chloe. I'm so sorry. Yeah. I'm out of sorts this morning. I walked in like as the bell was ringing. All right, so 16 says, write the system, yada, 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 as an augmented matrix, and then solve that system using Gaussian elimination with your calculator. Okay? So the augmented matrix we're going to write is basically this system, but we're not including the variable symbols, the addition, subtraction, equal signs. We're just including the coefficients. So the first row would be 1, 5, -2, -1. The next row would be negative 1, negative 2, 1, 6. And the last row would be negative 2, negative 7, 3, and 7. Okay there? I'll then use my calculator to do the RREF on this. And that's going to give me a matrix. I already called this thing off. There it is. I think this is matrix C. Let me check real quick. Yes, okay. So I'm going to do RREF on that matrix C. I've already entered that matrix C in my calculator. So that part's done already for me. So I'm going to do RREF on C. And I get all these wacky decimals. Probably makes more sense to look at the fraction version. So I can do math and frac. So there's my matrix. What is that telling me? How do I interpret that as an answer? Kind of, but not quite in this situation because something special is going on here. Andrew, I saw your hand up. Did you have... So how do I interpret this matrix to an answer? What do I see here? Yeah, so the last row is the one that we're really interested in. What that last row is saying is 0x plus 0y plus 0z equals 0, or 0 equals 0. So that's telling us we have infinitely many solutions. Now, we didn't want to stop there. We wanted to also give like the general form solution to this. And the way we're going to generate that general form solution is we're going to use these other two rows to help us do that. So row 1, as Andrew says, means 1x minus 1/3 z equals negative 28/3. And the second row says 1y minus 1/3 z is equal to 5/3. Now I notice that both x and y could be written in terms of z if I just add that z to the other side. So I can rewrite that first equation as x equals 1/3 z minus 28/3. And the second equation I can write as y equals 1/3 z plus 5/3. So now I have equations for x and y that are in terms of z's. So I can write my general form. So my x is going to be 1/3 z minus 28/3. My y is going to be 1/3 z plus 5/3. And then because I've written x and y in terms of z, z is like my independent variable, and that's what I'll choose to find the other two answers. Is that okay? Chloe, are you happy with that? Okay. So are you usually going to have to go through and find this general solution. What's that all about? It only happens if we have infinitely many solutions. And that's where I have a row all of zeros. Okay? If I don't have a row all of zeros, I don't have infinitely many solutions. I don't have to do this. Eli? Sure. Chloe, are you happy with what we did there? Okay. Who's next? Addie. Sure. All right. So, if I want to solve this by graphing, I have to graph each of these two equations and find their intersection, right? What shape of graph are these two equations going to provide? It's going to be like a V, a parabola, a line. What is the shape? An X. No. Each of these are a line. How do I know they're a line? It's a linear equation, right? The degree on, or the exponent on each the x and the y is 1. And there's no absolute value, or there's no square root, or there's nothing else going on. It's just addition and subtraction. So, all right. So, what I'm going to do, say I'll look at the first equation. I'll pick a value for x, say maybe 0. I'll then plug 0 in for x and figure out what the y has to be. 0 or negative 2 times 0 is 0. 0 plus 3y is still 3y. If I divide both sides by 3y, I get that y is 2. So I have the point 0, 2. I need another point. Am I limited to picking just x's? No, right? I could pick a value for y. Maybe I pick y to be 0 this time. Why am I using zeros as my choices? Just makes it easy, right? You know, like the arithmetic is easy. That's the only reason. Did I have to pick 0? No, you pick whatever you want, man. It's fine. 0 is usually a good choice, though. So 3 times 0 is 0. Negative 2x plus 0 is negative 2x. When I divide both sides by negative 2, I get x is equal to negative 3. So I get this point. So there's the equation of that line. When I look at my next equation, if I pick 0 for x, what do I get for y? Should be able to do that in your head. 4, right? So I have the point 0, 4. If I pick 0 for y, what do I get for x? 4. So there's 2 points. Draw my line. I know it was, but that's not the question I asked. So there's my intersection, which to me looks like the point 1, 3. So that should be my solution. Is there a way you could check that? Why don't you just type that in as a matrix and do the RREF on it, right? That just takes a minute. It'll absolutely tell you the answer, right? Did you say, huh? Yeah. I just graphed the 2 lines. There's lots of ways to graph a line. You know, did you write them as mx plus b's and then do it? Yeah. Yeah, that's fine too. No problem. Same thing. Everybody okay with this one? Addie, you feel all right? Okay. And again, like I just graphed the lines. There's lots of different ways you could have done that. Many of us probably used a different method than maybe I did there. It's 6 and 1/2 dozen of the other. The point is getting the right line on there. If you can graph the line correctly, I'm not concerned about how you're doing that, right? That's an Algebra 1 or geometry skill that you guys have learned several probably different ways to do that. So whatever you feel is easiest for you is fine, right? The point is finding the intersection of the two geometrically by looking at the graph, and that's the part that I'd be concerned about. So lots of different ways to graph a line. In fact, we haven't really talked much about how to graph a line. It's something that we've kind of assumed as prior knowledge, which I think is probably fair. When we talked at the beginning of the year, that was one of the main things you guys remembered from Algebra 1 was graphing lines and stuff. So don't get bent out of shape if you graphed your line different than me. That's fine. No big deal. Unless you got the wrong answer, then it's a little bit of a big deal. But who's next? Going once. Going twice. Any more questions? Okay, Grace. You can come see me during community time or something. Sure. Leslie? Right. Nope, I wouldn't worry about it. You're talking about the area of the triangle problems. Yeah, so did not make it onto the review, so I would not worry about that for the test. You can't test it all, right? So I prioritized these other problems that I think are more common for you to see going forward than that really specific, like, application to geometry, which, although it's a nice little trick, you know, it's not something like very common that we describe a triangle using the coordinates of the 3 vertices and then ask you to find an area. That's an uncommon way of phrasing that problem. Okay? Okay. We're good on the review. So, just